All right, let's look at verifying identities. When you're asked to verify an identity, what you have to do is show that the two sides are equal to each other. And the way you do that is by transforming one side into the other, or sometimes if both sides are pretty complicated, you might try simplifying both sides and transforming one side into something and then transforming the other side into the same thing. But what you can't do is move stuff from one side over to the other. So this actually comes up a good bit in calculus, especially in calculus 2. So what I want to do is several examples where we try to identify or try to verify an identity. Now, this first one I want to kind of talk about what I'm doing while I do it. This over here, I'm going to call this the left. No, this is the right-hand side, and I'm going to abbreviate that RHS. And this is the left-hand side. So when you work an identity out, what you want to do is start with one. You want to have a chain of equations where you have the left-hand side equals the right-hand side. That's the format I like to do these in because it's nice and clear. And typically what you want to do is start with the more complicated side. So on this one, the left-hand side is more complicated than the right-hand side. So the left-hand side, this is tan theta cosine theta. And a typical thing to do on these is to rewrite tangents or secants, things like that, in terms of sine and cosine. This is going to be a really quick one because all we have to do is rewrite the tangent as sine theta over cosine theta. And then we can cancel these guys and we get sine theta. And that is equal to the right-hand side. So we've got a chain of equalities here that show that the left-hand side is equal to the right-hand side. Let's do this next one. Secant theta equals that stuff. So in this one, this is obviously the more complicated side. That's the right-hand side. So we get sine theta times tan theta plus cotan theta. It's okay if you do something where you say the right-hand side equals, and you go ahead and make some small substitution here. So I'm going to go ahead and say the right-hand side is equal to sine theta times tan is sine over cosine, and cotan is cosine over sine. All right, what I want to do now is distribute this across here. When I distribute the sine, I'll distribute it here, and when I distribute it across here, it's going to cancel with that. So distribute that sine, I'm going to get sine squared over cosine, then plus just cosine. All right, now, we're aiming to get to secant. So we've got two things here. We should probably try to put them together. So I'm going to multiply this side here by cosine over cosine. And so that gives me sine squared theta over cosine theta plus cosine squared theta over cosine theta. Over here my thetas became x's. That's not a huge deal, but I shouldn't do it. All right, so we've got that, and now we know cosine. We've got the same denominator here, cosine, and up top we've got sine squared plus cosine squared. That's 1. So 1 over cosine is secant, and that is the left-hand side. So we're good. All right, you might notice I skip a few steps here and there. You don't want to skip too much, but things like going from here to here, without writing the intermediate step where you've got sine squared plus cosine squared over cosine theta. It's fine with me if you leave that kind of stuff out, because it's obvious that this is going into a single fraction and that this is going to be replaced with 1. All right, this next one. This one's definitely more complicated over here on this side. So let's see, that's the left-hand side. And what I want to do to this is, let's see, we're trying to get this to just be cosine. So I think probably what I want to do is rewrite this in terms of sines and cosines. So let's see. This would be 1 plus cosecant is 1 over sine. Secant is 1 over cosine. Then minus cotan. Cotan is cosine over sine. And I've changed my variable again. Let me switch these back to x's. If you do this on a problem, on a test, you change the variable. It's not that big a deal. I probably wouldn't take anything off for it if the problem didn't have thetas and x's in it, where you can get them confused. But let's keep the right variable name there. All right. So what can we do to this? I think probably. All right, here's what I want to do. Over here, we've got a sign for our denominator. Over here, we've got this denominator. Let's take this and multiply by the reciprocal of that. When I was in school, that's what we learned, multiply by the reciprocal. So we take 1 plus 1 over sine x times cosine x minus cosine x over sine x. I think a lot of people call this now keep, flip, change, something like that. Anyway, so I've got this here, and now I can distribute this cosine through there. When I do that, let's see, the first thing becomes cosine x, the next one becomes plus cosine over sine, and then I've got minus cosine over sine from the second one. So those two cancel, and I'm just left with cosine x. And that is my right-hand side, and I'm done. All right. So now let's see. This next one is the last example. I'm not even going to read it off, but we've got the left and the right side here, and on this one, I wouldn't say that one side is really any better than the other. So let's just let's start with the left side. The left-hand side is cotangent x over cosecant x plus 1. Now, it's not at all obvious what to do here. So here is sort of another tip. Sometimes it's helpful to multiply by conjugates. So I'm going to take this and I'm going to multiply it by 1. But the one I'm going to multiply it by, on the bottom I'm going to use cosecant x minus 1, then cosecant x minus 1 here. That way I'm multiplying by 1. And I get this just from taking that and changing the sign. Now the reason to do this is this gives you on top, well on bottom what it gives you is cosecant x, or cosecant squared x minus 1. And up top it gives you cotangent x cosecant x minus cotan x. Now, why do we care about this? Because this cosecant squared x minus 1, this is one of the Pythagorean identities. Let's go back up. I'm pretty sure this is just going to give us cotan, but let's go back to the top of this and see. Let's see. Cosecant squared x minus 1 is cotan squared. Yeah, so this will be, bottom just becomes cotan squared x. So now I can break this into two, actually I'm not going to break it into two fractions. I'm just going to factor out cotan on top. And I'm left with cosecant x minus 1. And on bottom, we got cotan squared. You can cancel this with one of those, and we're left with exactly what we're looking for. Cosecant x minus 1 over cotan x, which is the right-hand side. So we're good. All right, that is that's the last example. So anyway, we'll stop this section here.